spots in the entire park, if not one of the quietest spots in the entire country. It's really, really quiet here. We think part of that is because we have all of this moss. Kind of acts as a dampener and keeps it really quiet. So I always like to stop in these areas that have this kind of unique silence to them, because it's not something we get to experience in our everyday lives. It's this natural silence. So as you were listening, what are maybe some man-made sounds that you're used to hearing that you could not hear in this spot?
Traffic.
Yeah, we're not hearing all that car noise. We're not hearing trains, planes. No sirens.
People playing out loud on their iPhone.
Yeah, a lot less machine noise in general. Of course, we can still hear some people, and that's okay. We're allowed to make noise outside. We're part of nature too. But we don't have all of that machine noise happening here. So while you were listening, what are maybe some of those natural sounds that you're not used to hearing that you could hear in this spot?
Buzzing.
Wind.
The water coming to the trunk.
Totally. So we can hear the buzzing of bees and bugs. We can hear the wind in the tops of the trees. We can hear the river flowing over by, or the Hoh River, which we're not really that close to, but it kind of echoes through the valley a little bit. We don't necessarily hear a lot of birds or squirrels or animals right now, and that's just because it's too hot right now. But if you come out here in the early mornings or into the evenings, you're going to hear more of those animal noises. So it's really important not just to protect the natural landscapes of these places, but these natural soundscapes as well. We're going to have these quiet spaces, because those predators need to hear when the prey is out, the prey need to hear when the predators are out. So it's really important to have areas void of all that man-made noise. And I don't have to talk as loud, which is also really nice. But of course, we are not just here to appreciate this quiet space. We are also here to meet a couple deciduous friends. So the two deciduous friends we're going to be meeting today are both maple trees. One of them is the one that's kind of reaching over the trail here. So their bark is a little less important because you may not always be able to see it. So instead you want to look at those leaves. So this is a vine maple tree. There's actually two vine maples, but generally they're going to look like vines, and they're going to have 7 spikes on their leaves instead of the 5 of a classic maple tree. So very much look like vines, 7 spikes on their leaves. Sometimes they're categorized as shrubs, but they are actually a tree. So that is our vine maple. And as you're looking at the leaves today, you'll notice a lot of them are curled up. And that's because we were about 2 feet behind on rain for the year. So our trees are a little bit stressed out. It's been pretty hot, so they are a little bit sun scorched. What they're doing is they're curling up their leaves to hopefully get a little bit less sun exposure and keep them from getting too dried out. So their leaves are a little bit harder to look at, but generally they're going to be much smaller because the other star of our show is the big leaf maple tree. Does anybody want to guess how you identify a big leaf maple tree?
Big.
Yeah, they're going to have really big leaves. They're going to have that classic maple leaf with 5 points on them. So imagine the Canadian flag, but green. That's your big leaf maple. They also tend to be the trees covered in the most moss. And we get asked all of the time, is the moss hurting the trees? Which is a really good question. We're going to kind of talk about it together and decide whether or not we think the mosses are hurting the trees. So one really amazing thing about Olympic National Park is that we are kind of a living laboratory. We have a lot of different studies going on in this park. A lot of scientific breakthroughs have happened right here in Olympic National Park. And one of the studies that we had allowed a scientist to come into this park and strip one mature big leaf maple tree completely of its moss. She found some really special things in there. One of the first things she discovered when she peeled back all of that moss was that underneath it there was a layer of soil. This soil could be anywhere from 5 to 10 inches thick. So there's a lot of it up there. But it's not dirt like what's underneath our feet right now. It was made out of organic material. So it's made out of all the things decomposing in the canopies of our trees. So I'll pass this picture around so you can take a look at it. But as you are looking, you will also notice there is a bunch of roots in this soil. But there's one really important thing to know about mosses. They don't have roots. So where do we think these roots are coming from? Tree, yeah. So what's happening is that big leaf maples have a special adaptation that when their bark comes in contact with soil, they can start growing roots there. So our trees are growing roots out of their branches and into that canopy soil where they're accessing all the extra nutrients and moisture from those mosses. So I'll pass this picture around. So part of what's adding to this canopy soil and all the nutrients, of course, is all of the things that are living in the canopies of our trees. So what do we think lives in the tops of our trees? Yeah, birds, squirrels. There's lots of bugs up there. You can even find earthworms up there. Sometimes slugs go up there, not very often, but occasionally you'll find some slugs up there. We also have flying squirrels. They're super nocturnal. We really only see them from like 1 a.m. to 4 a.m. I have never seen one, but supposedly they're out there. So we have lots of things living in the canopies of our trees and adding to that organic material that is creating this canopy soil. One of my favorite things that is living in our mosses is known as the tardigrade. Also known as the water bear or moss piglet. So these guys are very, very small. They're microscopic. You cannot see them without a microscope, but they are very, very cute, of course. They're gonna have 8 legs. They use those legs to walk very slowly. Tardigrade, slow walker. But the very first scientist that discovered them originally called them water bears because he thought they looked like tiny little bears living in the water of this microscopic world. So water bears, moss piglets, tardigrades, they are just one small part of what's living in the canopies of these trees. So the cool thing about tardigrades, and I'll pass this picture around as well, is that they come in lots of different shapes and sizes. Generally, in our mosses here, they are mostly omnivores or they are herbivores. They're just going to be eating those plant cells or possibly the other microscopic organisms that are living in our mosses. But the great thing about these guys is that they are extremophiles. So that means they can live in really extreme environments. We can find them in the deserts, we can find them out in the Arctic. We have even sent them into space and exposed them to the vacuum of space, and they survived. So they are very, very extreme.
There's some on moon as well, right?
Yeah. So they aren't necessarily able to live there. So what happens is when they're in that extreme environment, they're going to curl up into a ball. That ball is called a ton state. So what they do is they tuck in all those legs, they tuck in their head, they curl into a ball. When they are in this ton state, they are neither considered alive and they are not considered dead. There's something in the middle, which we don't really have a definition for. But they can stay in this ton state for up to 30 years.
Wow.
So normally their lifespan is about a month, but if they are in that uninhabitable environment, they can be in that ton state for as long as they need to until they are back in that habitable environment. So when we find them in places that we don't necessarily expect to see them, most of the time they're in that ton state. And then eventually, once they get back into a place that has lots of water, is good for them to live in, they'll wake right back up and keep on living their lives. They're pretty special little creatures. We've tried to study them to see if they have the secrets to immortality, and they refuse to tell us. So we may never know. We do not speak tardigrade. But we know when that scientist came through here and she was taking the samples of these mosses, she also dried them out and weighed them. And she took a sample of this microscopic world. So when she dried it out, she took about 1 gram of moss, which is about the size of a muffin, and dried it out to see what microscopic organisms were living in the moss. And she found that we could have about 130,000 tardigrades in 1 gram of moss. So there's a lot of them up there. And when she dried out all of that moss, of course she weighed all of that as well. So how much do we think the moss on one mature big leaf maple tree weighs when it's dry?
200. No,
A ton.
500 pounds, a ton.
10 kg.
It weighed about 2,000 pounds. So yeah, just about a ton. So you can imagine if you're this mature big leaf maple tree and you're holding all of that moss on your arms, it's eventually going to make your arms start to droop. Which is exactly what we're seeing, is that they have these strange droopy branch formations. And that's because they're quite literally supporting entire ecosystems that weigh about 2,000 pounds on their arms when they're dry. But mosses specialize in retaining moisture. That's what they're made to do, is hold on to it. Some types of moss can hold up to 20 times their weight in water. So there's a lot of weight on these trees. But these mosses are on these trees because those really big leaves provide lots and lots of shade, right about now in our sunny season when it's a little bit more hot and dry. And then these big leaves are going to fall off, which allows those mosses to capture all of the rain that we're getting in the winter time. So they provide the perfect habitat for those mosses. So the mosses have been on these trees their entire lives. Which means the trees have had lots of time to do some weightlifting. They're ready for the weight of that moss. It isn't suddenly 2,000 pounds. So it doesn't really break branches off that often. It can happen occasionally, and it does happen. But generally, the trees are ready for it. So, do we think the trees or the mosses are hurting the trees? No, they're kind of working together. They're not fully symbiotic. In lots of environments, these trees survive without the mosses. The mosses can survive without the trees. But once this support system is established, they cannot survive without each other. So, when that scientist came through here and stripped all that moss off the tree, that tree ended up dying. We didn't know that was going to happen. She was one of the people who helped discover why there is so much moss on these trees. And now we know that they need these mosses. So once our forest has that support system, if they lose it, it can kill those trees. So that's a big reason we ask people not to take the mosses off of our trees, because you're taking all their friends, that support system. But we also know that some mosses grow so slowly that they can grow about an inch every 20 years. So they grow really slow. Which is another good reason not to take the mosses off of things, because they probably will not grow back. So we make sure to leave our moss and tree friends alone as we are appreciating them. But as much as I like to pretend that I am the center of attention, I know that I am not. So I will get out of your way and let you take some pictures. If you are on the guided hike with me or would like to join me, you are more than welcome to do so. We are about halfway done. I will meet you back at the beginning of this fur trail to answer any questions and give you time to take some pictures.
Thank you very much.
Of course.